So in this first page, you should read it. Basically, it's trying to get you to think about the domains and ranges of these inverse trig functions. And the same thing on the first part of the second page. So instead of, you can read this. Instead of doing this, I'm going to walk you through a couple of other things I want you to look at about this. So this red graph is the graph of. So here's what I've done here with Desmo. I graph the inverse of the sine. I switched x and y, and that's what this red graph is. And as you look at it, that's not a function. That fails the vertical line test. Okay, so what we've got to do is limit it somehow so that we've got a function. Because our arcsine is a function, right? And remember, arcsine is asking me, if I ask you, hey, what's the arcsine of -1? What you're really thinking is, what value has a sine, what angle has a sine that's -1? And of course, if you think about the unit circle, okay, that's down here, right? And that's -pi/2 if you think about it as negative angles of rotation. It's also positive 3pi/2, but we're going to deal with both positive and negative angles of rotation here. And that's why when we do the arcsine, if you were to type this in your calculator, you would get -1.57 whatever it is. That's what -pi/2 is in decimal form. So what we need to do is limit the output so that we have a function. So what we decided to do at some point in time, I don't know, is we're just going to limit it from -1 to +1 and only look at this part of that graph. So you see that blue graph is what the actual graph of arcsine looks like. And our output from the arcsine will be limited from -pi/2 to +pi/2. Okay? So I've done the same thing with cosine. This is what's being graphed here is the arc cosine, and then I've got it written both ways. Let's see, where's my pointer here? So here's when I just switched x and y, that's this graph, and then of course we got to limit it so there's a function formed just to this range here. So that tells me the domain of the arc cosine. Remember, we can also write it this way, right? No, not sine. Arc cosine x is going to be from -1 to 1, but the output is from 0 to pi. So you're only talking about this part of the unit circle. So then we start getting some really weird things here. The arc tangent is limited from -pi/2 to +pi/2 in its output, because if you think about the graph of the tangent function, you know how it goes like this and has asymptotes at -pi/2 and +pi/2. So that's what we're seeing here. So that's the domain. Well, the domain is all reals, right? Because tangent. Remember, tangent goes up, down to -infinity, up to +infinity. It just has the vertical asymptotes where x equals -pi/2 and +pi/2. So to limit it, that's what we call, that's the range of the arc tangent, I'm sorry. So for the remaining functions, those reciprocal functions, the reciprocal trig functions, the domain and ranges follow basically the same way as the reciprocal functions. And if you think about it, I mean, it really reaches the point where, like, we know the cosecant is a reciprocal of the sine, and the ranges kind of follow along the same way. I guess I wouldn't worry too much about these yet. They certainly aren't going to have a big impact on what we're going to do, a big effect on what we're going to do. So I won't talk any more about those. So since we have to worry about the domain ranges of the arcsine function, we only really need to worry about the first and the fourth quadrant for the answers here. We don't have to worry about 0 to 360. So arcsine is negative, tells me that it has to be down in the fourth quadrant, and that's 1 and that's going to be -1, and that's going to be 2, so that tells me that has to be 30 degrees, so we should write that as pi over 6. Sorry, negative pi over 6, what the answer to that one would be. Then, when's the cosine, the arc cosine? The arc cosine of 0 means when is the cosine of x equal to 0, right? So, think about the unit circle. 0 and 0 and 1 and 0 and -1 are the two places, but since we're worrying about the domain and range of arc cosine, we're going to just deal with from 0 to pi. That tells me pi over 2 is going to be that answer. So the arctan of root 3, well, let's see. The domain of the range of arctangent is from negative pi over 2 to positive pi over 2. Okay, then we're going to take and ask yourself root 3. So tangent is only positive up here. And that tells me that this is root 3 over 1, because that's the adjacent, opposite over the adjacent. So if we look at that, root 3 over 1 is that relationship, which is 60, which is pi over 3. Now this last one is the cosecant, so that's asking me when is the cosecant equal to negative root 2? Well, that's the same thing as saying when is the sine equal to -1 over root 2. We'll leave it unrationalized for a second. So the arc sine defined from negative pi over 2 to pi. Negative pi over 2 to positive pi over 2. And let's see, we get this. Arc sine's got to be 1 over root 2, so that's -1, that's root 2. That tells me that has to be a 45-degree angle, so negative pi over 4 is what we'd be getting out of the calculator. So how do we evaluate these compound trig, inverse trig, and these functions? You did some of this last year, but people tend to need some review. So we start on the inside, and they're telling me that the arctan of some angle equals 3/4. So I'm going to think about this as, hey, the tangent of some angle equals 3 over 4. So to draw a picture, let's draw, let's see, it's positive 3 over 4, so that's 3, that's 4, and that'll be 5, because it's a 3, 4, 5 triangle. And now, so here's the drawing that represents this. Here's the angle. We don't really care what it is. They're asking us now, hey, find the sine of that angle, whatever it is. Well, the sine's going to be 3 over 5. It's that easy. So again, we're starting on the inside. We want to know what angle has a cosine that's root 2 over 2. Well, we don't really want to know the angle. We just want to draw a triangle. So remember, root 2 over 2 is the same thing as 1 over root 2 rationalized. So here's the angle we're talking about. So this is 1 over the square root of 2, and if you think about this, you kind of know this is a isosceles right triangle. So then we ask, what's the tangent of this angle? We've got the angle drawn now. Now what's the tangent? Well, the tangent's opposite over adjacent, so that's equal to 1. So now for this next one, the inside is asking us the sine of x is equal to 1/3, and they want us to find the angle, or at least draw a triangle that represents this. So 1 over 3, and this of course will be the square root of 9 minus 1, or the square root of 8, which is 2 square roots of 2. And now they're asking us to find the secant of that. Well, the secant is the reciprocal of the cosine, so that's going to be 3 over this. So 3 over 2 square roots of 2. If we rationalize this, square root of 2 over the square root of 2, that's going to give me 3 square roots of 2 over 4. It'd probably be the better way. This is a perfectly fine answer. That's rationalized, though. Okay, so for this one, where's the cosine equal to -2/5? Well, if we think about the range of the arc cosine function, because that's what we're dealing with, is the arc cosine. We know the arc cosine has output range from 0 to pi. So we're going to be talking about it over here in quadrant 2. So that tells me it's -2 and 5, and this is going to be 25 minus 4, so the square root of 21. And it's positive in that quadrant. So the cotangent is the adjacent over the opposite. So I'm going to write -2 over the square root of 21. If we rationalize that, of course, I'm going to get -2 square roots of 21 over 21. Either answer works for me. So I think now for this next part, now we're not going to get a number answer, we're going to get an expression. And I almost think that to help you along the road and then for what we're going to do next is, let's think about this. So this inside expression, I'm going to think of that as, hey, some number, some that's equal to the sine, y equals the arc sine of x. Well, what we can do is we can rewrite this in terms of if we take the sine of both sides of this expression, won't that tell me the sine of y equals x? And I also know sine's opposite over a hypotenuse, so that's got to be a 1. So if we draw something here, think this is x and that's 1, we're going to find the other side of this triangle, which is just going to use the Pythagorean theorem of 1 squared minus x squared, and take the square root. And see, this is the angle. This is that angle y. I kind of introduced that, but that's the angle we're talking about. So now they want me to find the sine of that angle. I mean, the cosine of that angle. So cosine is just the adjacent over the hypotenuse. So this is going to be 1 square root of 1 minus x squared over 1, which we don't have to write. So again, I'm going to go with the inside of this, and I'm going to say, hey, some angle is equal to the arc cosine of x. So to make this easier, we're going to take the cosine of both sides. So say the cosine of y. Remember, taking the cosine of the arc cosine should cancel it out. And this is over 1 because it's adjacent over the hypotenuse. So we've got a triangle that looks like this. The adjacent side is x. The hypotenuse is 1. So this opposite side, according to the Pythagorean theorem, will be 1 squared minus x squared, and we'll take the square root. So now they're asking us to find the tangent of this angle y that's right here. So opposite divided by the adjacent is how we find tangent. So the square root of 1 minus x squared over x is what that expression is equal to. So again, for this next one, I'm going to say that for C, so y equals the arc cosine of 2x. So if we take the cosine of both sides, that tells me the cosine of y equals 2x over 1. So this triangle looks like this. 2x is the adjacent, 1 is the hypotenuse, and this will be 1 squared minus 2x squared, and we're going to take the square root, and of course I could have written this way. And now they're asking us to find the sine of that angle y that we introduced, so that's just going to be the opposite over the hypotenuse. So one last one. So y equals the arctan of 3x. So the tangent of y equals 3x over 1. Here's our triangle. Here's angle y. The opposite side is 3x. The adjacent side is 1. Pythagorean theorem says 3x squared plus 1 squared, and then we take the square root. So that's really equal to 9x squared plus 1, and of course we're taking the square root of it. Now they're asking us to find the sine. So the sine is opposite over the hypotenuse. So we're going to write this as 3x over the square root of 9x squared plus 1. And we are not going to rationalize that. We're going to leave that right the way it is. Okay, so now we're all set and ready to take a derivative. So I'm going to walk you through Stu Swartz example right here on this next part. They're asking us to find the derivative of the arc sine. So if we think of y being equal to the arc sine of x, we can do that same trick of taking the sine of both sides of this equation, and that's x over 1. Let's draw our triangle. So x over 1, and this side is going to be 1 squared minus x squared, and we'll take the square root. So now, and that's angle y, so now we're going to take the derivative of both sides. So the derivative of sine is cosine. So cosine y, but because we're taking the derivative of y, we need to make sure we do implicit differentiation and write that as dy dx. And then of course the derivative of x is just 1. So now to solve this, I want to solve for dy dx, so I'm going to divide both sides of this equation by the cosine of y. So dy dx equals 1 over the cosine of y, which we could write as the secant of y. Well, here's our triangle. The secant of y is going to be 1 over the adjacent, right? So that's what the derivative of that is going to be 1 over 1 minus x squared, and of course it's got a square root in it. Okay, and notice that's what Stu Swartz has right there. And that's the process. You can memorize formulas if you want. Actually, I think it's easier just to memorize the process, to learn the process. So let's do a couple more. So I'm going to say the cosine of y equals x, and it's x over 1. So I'm going to draw my triangle. I know the adjacent is x, the hypotenuse is 1. This side, remember, this is angle y right here. This side is going to be 1 minus x squared. Now we're going to take the derivative of both sides. The derivative of cosine of y is negative sine of y times dy dx. And the derivative of x is 1. So now we're going to divide both sides of this equation by negative sine y. So dy dx equals negative 1 over the sine of y, which is the same as the negative cosecant of y. And let's see, so the cosecant is the hypotenuse over the opposite. So the derivative of that's going to be, move this up so we can, so it's going to be dy dx equals 1 over the square root of 1 minus x squared. Oh, and it's negative. Okay. And here we go. So we've got, we know the tangent of y equals x. So an x over 1. So we're going to draw that triangle again. We know the opposite is x, the adjacent's 1, this side is going to be x squared plus 1, and we're going to take the square root. Now we're going to take the derivative. Well, let's see, the derivative of tangent is secant squared y, and then we need to remember to do dy dx. That equals 1. So dy dx equals 1 over the secant squared of y, which is the same as the cosine squared of y. So that's the cosine of the angle y squared. Well, the cosine of angle y is 1 over that square root mess. If we square it, it disappears. The square root disappears. So the derivative of this is going to be 1 over x squared plus 1. No more square root. So we've got in a nice little table here these formulas. Remember, he has du dx's because if u is something other than x, we got to remember to do the chain rule. Okay, so memorize these if you want. Like I said, I'd rather you memorize the process. It's a lot easier, takes up less memory space to memorize the process. So so I'm going to use that process, not these formulas, to find these last derivatives. So I know I'm going to take the sine. So for a, I'm going to take the sine of both sides. And that's over 1, so I can draw the triangle. So the opposite is 4x, the hypotenuse is 1. This is going to be 1 minus 16x squared, right? And I got to take the square root of that. So now we take the derivative of both sides, so the cosine of y times the implicit differentiation, dy dx, equals 4. Now I'm going to divide both sides by cosine y. So dy dx equals 4 over the cosine of y, which is the same thing as 4 times the secant of y. And if that's angle y, we know the secant is hypotenuse over the adjacent. So this becomes 4 times 1 over the square root of 1 minus 16x squared. Or we can just think of that as 4 over that. Now how does that gel or correspond to the formula? Well, notice it's if the u is 4x, right? If the u is 4x, we're going to get the 1 over the square root of the u, which is what that is, and the du dx is just the derivative of 4x, which is 4. So that's how we got it. So, I mean, if you like the formula, memorize it. I wouldn't otherwise. Okay, so the next one, we're going to say the tangent of y equals x cubed over 1. So I'm going to draw my triangle, opposite, adjacent. Hypotenuse is going to be, let's see, x cubed squared is x to the 6th plus 1. Here is angle y. So now we're going to take the derivative of both sides here. So that's the secant squared of y times dy dx equals, the derivative of this side is 3x squared. Now we're going to divide both sides by the secant squared of y. So 3x squared over the secant squared, which is the same as 3x squared times the cosine squared of y. Well, let's see. Cosine squared, well, 1 over this is the cosine, but we're squaring it, so the square root disappears. So we can write this as 3x squared over x to the 6th plus 1. So for this next one, I see a function, I see a power function, which I can just bring down the 3 and take away 1 times that, but then I got to apply the chain rule. So the chain rule is going to be the derivative of that arc cosine. So let's get this started. So I know it's going to be, so y prime dy dx equals 3 times the arc cosine of x over 2 to the 2nd power times the derivative of the arc cosine of x over 2. So we're going to solve another temporary problem here. I'm going to say, hey, I know that I'm going to say u equals the arc cosine of x over 2. So if I take the derivative of, if I take the cosine of both sides, then I'm just back into that same process. So my triangle looks like this. The adjacent is x, the hypotenuse is 2. This side is going to be 4 minus x squared, and of course I'm going to take the square root. So now I'm going to take the derivative of both sides. I'm going to get negative sine u du dx equals the derivative of x over 2 is the same as 1/2 x. So that's 1/2. Now I'm going to divide both sides by the negative sine u. So du dx equals, now dividing by the sine is the same as multiplying by the reciprocal of the sine, which is the cosecant. So now if this is angle u, the cosecant is hypotenuse over opposite. So I can erase this. Let's see, where's my eraser? Will it let me erase that? I'm going to cross that out. Now I'm going to write here. I'm going to write 1/2 times, now the cosine is going to be 2 over 2 over the square root of 4 minus x squared. And of course there's a negative in there, right, from this negative here. And then the 2's cancel out. So the answer to this chain rule part of it is going to be -1 over the square root of 4 minus x squared. And of course we're not going to clean that up. Okay, so they can get very involved. I'm going to do, just because I don't want to have to be limited by this iPad's recording, I'm going to save and do this last one in class. Okay, so now let's take a look at this last one here. Again, I think I'll save and we'll do this one in class. Now, if you get some time, you can go ahead and start the exercises on the next sheet if you want.